Alright everybody, welcome back to another Ask a Dev Unreal Engine tutorial. My name is Kevin and today we're going to be continuing our control rig series and we're going to be talking about inverse kinematics. So all of our series, all of our videos, they generally come by community request. We have a great community. If you're not part of it, feel free to hop in. We have Discord and Patreon links down in every video description. Don't forget to check out the live section. A lot of our videos are in the live section because we do live weekly tutorials. Don't forget that. So without any further ado, let's just hop straight into inverse kinematics and what we're going to be talking about today. So we've already talked about control rigs, setting up our controls, our shapes. We've talked about forward kinematics and we briefly mentioned that inverse kinematics and what it was. So let's recap that very quickly. We're going to open up our Manny character. Basically, inverse kinematics is the mathematical way of solving the resulting angles of all of the joints in a chain based on the end position. Now, if you remember, the way we talked about the inverse kinematics is a lot of times we want inverse kinematics for anything that has a point of contact. So as an easy example, best visualized by example, this is what we're going to be building today. And as you can see in here, generally speaking, what we want is if we move our pelvis, our legs will stay in place and our knees will bend. Or if we move our feet, the knee position will bend to accommodate wherever we move this end position to. Now, a lot of times the end effector is actually called the effector, or the IK effector. And basically it's because it is affecting the entire IK solution and calculating how much bend should be in the knee in order for the leg to hit this pose, as an example. So forward calculates the angles based on the settings of each of the joints down the chain. Inverse calculates back up the chain in the inverse direction based on where the end point is. So this is what we're setting up today. Let's get started. So first thing we need is we need to create a control rig. We're going to start from scratch for now. These are fairly straightforward. So the way we do that is we take our Manny Simple, we right click on it, we choose create, and we're going to create a control rig. And we are going to call this the Manny or control rig Manny Simple IK. Okay, when we open this up, we are going to need a couple of controls to work with. So here's what we want to do. Using our rig hierarchy, let's create a center of gravity control so that we can test out our control rig. And then we're also going to need a foot control for each of our IK solutions. So let's just go ahead and create those. I am going to, you know what, we'll just create these freehand. So let's just go new control. I'm going to call this the layout control because I like to have a layout control. I'm going to duplicate that. I'm going to call this the cog control for center of gravity. If you're new to this, that's going to be like a lot of times on some rigs, it's called the body control, whatever. And then as I mentioned, we're going to need a left foot and we'll go ahead and make a right foot too. Left foot and a right foot. Now, let's go ahead and colorize these a little bit and make them useful. So our layout control, as before, I am going to make this a large hexagon thick, and we'll make it yellow because as I mentioned, I like to make all my center controls yellow. Same thing for the cog. We could have probably done both of these at the same time. And then for our feet, what we're going to do is we're going to make the left foot a cube. I like using a cube or something that is not a circle. There's two reasons for that. One is when I rotate a cube or a diamond or something like that, I can see it rotating. Whereas if I use a sphere, it's very difficult to tell as an animator how much I'm moving it. That's one reason. Second reason is for things that I rotate, I like to use circles and spheres, and for things that I translate in world space, I generally use some other shape, whether it be a pyramid or a diamond or something like that. It's just the way I was brainwashed when I was learning how to rig characters. That's what it is. I like it as a paradigm, so I'm sticking with it and just kind of explaining a little bit about why I do that. Same thing for the right foot. Let's go box thick. And the left foot is going to be blue. And the right foot is going to be red. Right is red. Okay, so what we need to do is we need to set some of these default positions. Let's go ahead and do some quick scale here. Block this out. This is going to be our layout control. And then let's change this to lock this to 8. We'll keep our foot sizes the same. All right. So as we did in the forward kinematics video, we do need to do a little bit of construction. We want all these controls to go into place. I am going to go ahead and set these in construction script. This is a little bit different than what we did last time, where we built the controls in place and set their offsets. So just again, the goal of these videos is to teach you all of the different inner workings of how control rig works. You can pick and choose the pieces that apply to you as you go. So let's go ahead and create our construction script and our construction event. The layout control we're not going to move. The cog control though, we are going to set the control, and I'm going to get the position of the pelvis. So let's just go ahead and get this bone. And I'm going to feed this into our cog's initial position. And when I compile this, we should have, I'm going to set this to initial. All right. And then what we should, now you'll notice that my cog is now in position. I do want to check how it's aligned in world space. So right now this is actually X up. So I don't think I want to do that. I think I want this to be world aligned. So let's undo that. And let's just take the translation only. Okay, that way it's aligned to the world, just like our layout control, for example. All right, so that is a good initial position. Now, when I pick my cog control, I do want to check to make sure I don't have any rotation or anything on any of these initials or currents, etc. Great. So now let's just do the same thing for our other controls. So let's line up our left foot. So we're going to set the control, and I'm going to get my left foot position. Let's see here. Here's our foot. Let's get the bone, and I am going to align this perfectly to that, and I'll show you why in a bit. So we'll set our initial on that. So our left foot is now in place. You can see these are popping into place as we go. So now the blue is aligned to the left ankle, and we need to do the right ankle. So we can just copy paste this and change these to right. So the item on this case is going to be the right foot, and the item on this one is going to be the foot R. Okay, so we have all of our controls in place, and we are ready to create our IK solver. Now, the actual IK solver part of this demo is very straightforward. It doesn't get tricky until we get into pole vectors, and I'll explain what those are in a second. So let's talk a little bit about the solver. We have all of our controls in position where we want them. What we need to do is we need to create what is often referred to in most softwares as an IK setup or IK solver. So somebody wrote a whole series of tools or code that basically will do all of the math to figure out what the angle of the knee needs to be. And in Maya and in Blender and in Unreal, those are called the IK solvers. And in the case of Unreal, what we are going to use is we are going to use a basic IK setup. Okay, so two things we need to do. Let's go ahead and set the position of our pelvis first based on our cog controls so we can move our character. Otherwise, we're not going to be able to see the knees bending unless we're using just the feet. So to do that, let's take the control, let's get the control, and actually I do want to parent these. I missed. I'm going to drag the cog under the layout, and then I'm also going to drag both of my feet under the layout just so they're there. Okay, cool. So now we have some hierarchy set up. That's great. I'm going to save this just in case. Crashes are always a thing. I've noticed, especially when working with control rig, it's worthwhile to go ahead and save often. So let's set the bone here. This first bone that we're going to be setting is going to be our pelvis, and we're going to be setting it based off of the transform of our control. Now we have a little bit of a problem, and that is because we did not rotate this into place. So remember, we didn't take the initial rotation. So for the purposes of this, we're just going to take the entire transform, not just the in the initial setup in the position. There's another way to fix this, and this gets into projecting into parents and setting up relative stuff. We'll do that in another tutorial, but for now, let's just get the initial bone position for the pelvis, feed that into the initial position for our cog control, and then on our cog control, we can just rotate this 90 degrees so it looks like it's in the right space. All right, because once again, the focus of this is the inverse kinematics. All right, so here we go. We have our cog control. This is all in place. And now if we pick our cog control and we move it, our whole character moves. That's great. Now, interestingly enough, our feet don't move. That is okay, because generally we're going to want our feet to stay planted anyways when we move our cog control. So now let's get into the IK, basic IK. So here's all we're going to do. We're going to drag off here, and we're going to choose a basic IK. Now, let's talk about a bunch of these settings. So generally speaking, the way most of these IK solvers work are you need to give it the upper bone, the middle bone, and the end bone or joint, and then you give it a couple other features that we're going to talk about here in a second. So the first things first, we've got a bone. Let's go with our thigh, which is, we're going to do the left side first. So we're going to do the left thigh, we're going to do the left calf, and we're going to do the left foot. Okay, the minute we do that, you'll notice that our leg is already doing something. It looks a little bit weird, but it's already doing something. And that's because we need to give it a couple of little bits of information, because the solver needs to know which way is forward and which way the bones are facing and all those kinds of things. So in the case of this left leg, what we need to do is our primary axis is going to be, I'm going to use a -1 for X. And then for the secondary axis, I'm going to keep that at the 0, 1. And then let's see here. Yeah, so we're going to leave all of that. Now our leg actually has a solver in it. Our ankle's broken a little bit. We'll talk about that in a second. But if we move this, you'll notice that my leg is now counter animating. Now there's a couple of weird things about it. Why is this happening? So what's happening is our end effector, this piece here, is not currently rotated in the same space as our foot control. So what we're going to do is we are going to get our foot control, and we are going to try, let's just get that control, and we're going to feed this in to our effector. All right, the minute we do that, now it knows which way or where this end effector is going and how it's supposed to be positioned and rotated. So this already looks a little bit better, but we still have a problem with our knee. So what is going on with our knee? Basically, when you calculate inverse kinematics and you're trying to figure out which way the knee bends, you have to have some way to help the solver understand which way is forwards. And usually that is done with an extra node or a vector or something that basically tells the solver which way is forward. So in this particular case, and usually that is called the pole vector. It's the director. It is, I think it references the pole in the math, like as in the polar poles, but I think of it as which way it's pulling the knee. And in this case, right now you can see it's actually set to pull the knee in 0, 0, 1. So let's see if we just set this to 0, 1, 0, if we can get a better look on our knee. Nope. Still not there. Pole vector kind is a direction. Let's try 1, 0. Okay, you could see it move slightly, but not. It didn't do a whole lot. Let's try 50. There we go. All right, so we needed bigger numbers. It's actually using a full-on direction. So if I use a number like 50, you can see now my knee is a little bit straighter. Okay, and now when we bend our knee by either moving our body down, okay, or by moving our foot up, you'll see that our knee is bending a little bit more forward. However, it's not perfect. But bottom line is, this is it. This is how you make an basic IK setup. You give it the 3 joints and an end effector, and then it will automatically calculate what those angles should be. The trick, and this is, so the setup of the IK is easy. The tricky part is the setup of the pole vector. So let's talk a little bit about how to get this pole vector perfectly aligned and some things you need to understand about your rig to clearly understand how this works. So let's talk a little bit about joint orients and etc. So here's a version of Manny that I've pulled into Maya, and if we take a look at this, I'm actually going to hide the geo. So if we just turn off our geometry, all right, from here you can see we have our upper leg and our lower leg. Now most IK solvers, as I mentioned, they take an upper leg, a lower leg, and a foot. And then what they do is they calculate the rotations based on the plane that is defined by these three points. What does that even mean? So let me show you what I'm talking about. And let's hide this geo. All right, so if I create a plane, and it is basically just let's go flat shading so you can see it better. Basically, there is a plane that is defined by these 3 joints. It is created by, if we were to take 3 points and place them, you can see we've created this geometric shape that looks like a plane. If I make it bigger, you can see it. Now what's important about this is that this is generally the most stable direction, at least for all the IK solvers I've ever worked with. So what's important about this is you want each of these joints, the upper leg, the lower leg, and the foot, to be aligned to the plane. And that is why when you pick these joints, and actually I've actually messed up the orientation, I actually rotated. When you pick these joints, when we pick any of these and we turn on the axes and we go, what you want is you want these to be in line with this plane, generally speaking. All right, and a lot of effort is put into making sure that that is the case. Now when we do that, what that does is that gives us the most stable solve for our IK knees and the locations of where they're going to end up. So using that knowledge, using the knowledge that we want our joints to be oriented to be in the same direction of the plane of the IK solver, or the plane that is defined by the points in the leg, we are going to use that to decide where our pole vector should be positioned for our setup. Whew. So let's go back and talk about 2 different ways to align our pole vector perfectly, because look what happens if we don't. Right now, we're just picking an arbitrary point. If I disconnect my forward solve, I want you to watch what happens to this knee. See how it pops? We don't want that. We don't want that, because what that means is every animation potentially that's created with this setup, if it's incorrect, is going to have a slight offset in the knee. So the idle, etc., when we start doing additive animations and all those things, it's bad. Let's just go with it's bad. All right. So how do we get the knee aligned perfectly? All right. So method 1, we are going to use the knowledge that the joint is rotated correctly to point in the vector of the plane defined by the 3 joints. All right. What does that even mean? Here's what we're going to do. We are going to create, for the left calf, I'm going to add a null. Okay, and I'm going to call this left knee PV reference. Now, when we look at this, we can't actually see it right now because visualizing nulls can be tough so far. But what we can do is if we move this, you can see, let me zoom in a little bit here. And let's just go ahead and do this too. Let's go 1.1 on this. make our fonts a little bit bigger for you guys. All right, so if we move this, you'll notice that there's a joint that's moving at the knee. Okay, remember, our knee is aligned properly to the plane, so we just want to move this in the y-axis. All right, you'll notice that as I move this out in the y-axis, this sticks straight out the front of the knee. And it does so in the plane that should be defined by, assuming that these joints are oriented properly, this should be done in the plane of what we're looking for. And I want to make sure that this is in fact local. Yep. Okay, cool. So here's what we're going to try to do. If we actually undo this, let me disconnect that temporarily real quick so you can see. Our twist was already messing us up a little bit. Let's pick this. Oh, and I need to do that. And also make sure we do this in initial. So I'm going to do this in the initial. Actually, what I'm going to do, I'm going to do this in the current. And I'm going to use this as a reference. Let's just move it, let's say 50 out in front. Okay? So when I do that, you'll see that that looks like it's more in line with the knee. All right, then what I'm going to do up here in my setup script is I am just going to go ahead and I'm going to, at the beginning, I am going to force that knee to be correct. So let's just take this knee pull vector ref and I'm going to set the null and I'm going to set it to be local space because we're using the fact that our joint is reference. We're going to use initial and the value I'm going to use is going to be 0, 50, 0. So that positions that pull vector right where it needs to be. Okay, so now that we have that, we know exactly where to put our pull vector for our IK setup because we have this knee pull vector reference. So if we go back down and we reconnect this, let's see if we can't fix this. All right, so first off, we reconnected it. Our pull vector is messed up because it is actually using just a random number that we chose. If we wanted to, what we could do is we could take this pull vector, if we get this null, and we feed this into our pull vector, you'll notice that now my knee is pointing in the right direction. Okay, so if we what I want is when I disconnect this solver, the knee does not move. That's what I want. When I reconnect it, the knee does not move. That way, I know that no rotations are being put on this joint as a result of the math in the solver because I've set it up properly. So we basically aligned the plane for the solver using the knowledge that the rotations of the joints are correct and basically placing a little bit of a reference node using a null to figure out where our knees should be. All right, so that's method one. We can use a reference node or null or the knowledge of these joints. Now, let's talk about method two. Now, also, what we want to do actually is we do want to give our animators the ability to control these. So here's what we're going to do. Let's create a pull vector control. And what I'm going to do initially is, actually, let's just add a control. We're going to add this under the left foot. I'm going to create a new control. I'm going to call this the left foot PV. Oh, and I actually meant to put control after all of these, by the way. Left foot, this should be the control. Control, for example. Okay, well, let's make sure this is blue. And I'm going to turn this, into a diamond. Thick. No, not a diamond. Pyramid. Let's do pyramid. Pyramid thick. And for some reason, it is still red. We want it to be blue. Okay, great. Now, I also want to position this to be at this same position as we got for our local space. So what we can do is, now that that's set, we can set this. Let's set this position. We'll set the control. Let's set our control position to be, whoa, didn't like that, did it? We're going to go with initial, and we're going to get the, let's get these. We could do it a couple different ways, but we could just get this. let's get the null and we'll feed that into here. Okay, cool. So now we have a position in space, and I'm going to rotate this control 90 degrees. I believe we're going to go 90 in, let's try Z. Let's do -90, even better. Okay, so now it's kind of facing the right way. I'm happy with that. That looks good. All right, so now rather than connecting our pole vector to the original null we set up, we're going to connect our pole vector to this control. So let's get the control instead, and I'm going to show you how this works now. So if we get this translation pole vector, okay, so now what happens is wherever we move this control, you'll notice that it affects which way the knee is aiming. And this is cool because what happens is if we bend our character, if our character goes to kneel down, for example, or for example, they want to move a foot out to the side, and let's say we just rotate it, but I want the knee to be moved. Maybe it leans a little bit more inward because it's a crab walk, or more outward because they're doing ma-bu. Who knows what it is? Ma-bu is horse stance, by the way. Whatever it is they happen to be doing, you have now given the ability for the animator to control these knees. And now, another reason that we want to do this is because the solvers are not perfect. There are positions that you can pose a character in where it will confuse the solver. This pole vector helps stabilize that and allows an animator to correct or fix knee positions as well when you get into funky positions. So we have now set up the IK, basic IK setup for the left leg, given the animator control, etc., using our node, our reference null as a positional calculation for the pole vector. So the basic IK setup, super straightforward. Drop in a basic IK, 3 points, etc. The fun in this is getting the pole vectors right. So that was method number 1, using a reference null and the offset from the knee. Now let's use another way. This one where we don't have to use this null. What we can do is we can also use the same knowledge of the rotation of the knee and place it based on that. What do I mean by that? If we go to our third person character and we just take a look at what it looks like, I've dropped in this arrow as a piece that I can use as a visual reference to explain to you what's happening. So in general, when we look at which way this knee is facing, we know, for example, based on our current pole vector facing, this knee plane is slightly off to the side. So what's happening is, what we can use is we can use a little bit of vector math. So if we take the rotation of the knee and we get a vector from it, then what we can do is we can take that vector, like let's just say, I'm going to exaggerate, let's just say this was our knee facing. All right, using that vector, we can now take that and we can offset that to the location of our knee. Basically, using a little bit of math, we would move it up to here, and then we can place the pole vector at the end of that vector. Okay, so we're going to be doing a little bit, not too much, a little bit of vector math. So here's the plan. Let's go back and do that for our left knee. So we're going to go ahead and let's see here. This is, oh, we're setting the, which item are we setting here? Oh, this is our foot control. We want to set this before we set our pole vectors because our pole vectors are parented. You got to pay attention to order here. So our pole vector, let's do our pole vector last. Setting transformer parent, left foot control. After setting left foot pole vector control. Item. That's the knee reference. Item. Here's our pole vector control. Let's move this to the end really quickly. Just so that at least we're in the right order. Okay, that gets rid of that. All right, so here's what we're going to do. This is method 1. Let's go ahead and let's move this up here and just put a comment around it. This is going to be null reference pull vector placement. All right, now let's do the vector version of this. So first thing we need to get the calf bone. So let's get the calf bone. And what we're going to do is we're going to get the rotation of that. And from that, we are going to use that rotation to rotate a vector. So let's rotate a vector. And the vector that we're going to rotate is the distance we want our pull vector position to be out in space. So if we wanted it 50 units, 100 units, and another good question to ask here is, how do you know how far away to place your pull vectors? Well, generally speaking, you want them at least far enough away so that when you bend the character's knees, the knees don't go past the pull vector, because otherwise that'll confuse it and your leg will flip to face the other way. So generally a distance that is larger than a bent knee position for your character is a good place. Animators will usually update that based on what they like. So again, continuing with our 50 units, this is basically going to take a vector and rotate it. It's going to take the vector 0, 50, 0 and rotate it to match the same facing as the knee in this case. And then what we're going to do is we're going to take the result of that and we're going to add it back to the original position of our knee. Now, if you are looking at this and you're like, vector what? There is an entire video on basics of understanding vectors, and that would potentially be a good one to check out if this is confusing to you. But effectively, we're taking a vector that goes from 0 to 50, we're rotating it to match the same facing as our knee, then we're taking that vector and we're moving it up in place, because remember, vectors have a magnitude and direction. We've got to give it a start point. So that way, this resulting position will now be the placement position for our pull vectors that we want to use. So what we're going to do is we are going to, rather than setting this with the null here, let's copy this down and let's plug it in here. Okay, so, and what we're going to do is we are going to place this into the translation. So wait, if we compile this, by the way, right now, our knee pull vector disappears. It is, I'm not even sure where it is, but if we go ahead and bring this back in to our translation, did you see that pop into place? So it looks the same, but let's just go ahead and back off our knee reference just so that we can see this. Oh, okay, over here in their code, we have at the very beginning, let's just back this off to 10. So it's still there, but you can see that this placement is actually now being done based off of this vector that we've created. So we've now placed our pull vectors based on the facing of the knee. Now, this is a little bit more like the solution that you would see if you were to look into the default control rig that comes with third-person character. They use an AMAT setup, but I felt like these two methods were potentially easier to wrap your head around because remember, either one of these, it doesn't matter. Any of these, the goal is to get a knee position for this pull vector that is in line with the current facing of the knee, so that down here, if you disconnect this, the knee does not move. You should not see your joints move when you disconnect that. Otherwise, you're inadvertently putting small rotations on the bones and the joints that you do not want there when you're saving out your animations and things like that. So that is the second method, basically using vector aiming to line up your knee pull vectors. So that covers those two methods. Now, in each of these cases, now whenever we move our feet, we can place this, and then we can take this as an animator, and if we want to, we can move it off to the side. Now, if we were to try to create an example of what I was talking about confusing, real quick, if you get this too close to the base, the solver is having a huge problem figuring out how to calculate this angle. So by giving you access to this pull vector, we can basically force where this knee should be as the animator. All right. Now, the thing to note that is at least worth mentioning before we wrap up today, if we compile this, take a look at our other knee. Our other knee, the facing of our other knee, and actually it's probably best seen if we go into the skeleton. So if we pull this over here, the right knee faces a different direction because it's mirrored. So you'll notice that if we look at the translations of the left knee, Y is pointing out the front. If you look at the right knee, Y is pointing out the back. So when you set up your right knee, and you can see it very quickly here, I'll show you real quick. If we were to create a null for the right knee, let's do this right here. Let's add a null, new null, and we'll call this, we will call this the right knee pull vector ref. Okay, when I look at that, if I were to try to place this in the same position, let's connect this in, connect this up. All right, and we change this to our right knee pull vector ref. We change this to 50, for example. When you look at that, you'll notice that that 50 is out the back of the leg. That's not where you want your pull vector. You want your pull vector out in front. Generally speaking, out in front. There's probably some rigging exceptions, but remember the goal here is to keep this stable. And this is probably the most used method that I've seen, especially when working with animation and animation controllers and setups. So the point here though is, in both cases, when you're using 50, just remember for the other side, for the right side, you have to pay attention to the orientation. So for the right side, it's a negative 50. And the same applies to this vector math. The vector math for the left side, you need to multiply this output by a -1 to get the vector to point the other way. So that wraps up a quick introduction to inverse kinematics, how to set up an inverse kinematic basic IK solver in Unreal Engine, as well as the tricky part, which has nothing to do with the solver. It's really all about the pull vectors, but hopefully with a better understanding of how and why your character's legs, and this also applies to arms, the plane defined by the shoulder, the elbow, and the wrist. Very important, same exact thing. The pull vector would come out the elbow in the plane of the arm. It applies to both. So hopefully the understanding of why those joints are set up the way they are, why and how that understanding helps us place those pull vectors in a position which is the best and most correct position for the way the basic IK solvers are set up. As always, thanks for checking out the video. Don't forget, if you like what we're doing here, help us out, spread the word. And as I mentioned at the beginning, we have the community, we have the Patreon, we have the Discord. Hop in, ask questions there, and we will see you on the next training. My name's Kevin. Take it easy.